Hey, the average Joe here. Hey, May is our birthday month. 23 years ago, this month, this software was started. As part of that, we want to help you with your projects. So in the email that was sent out, you can click on and sign up time to let us help you through a project or help you get started on one. I had a few questions once again from some users that just wanted to know some basics in the software. The first question was here, changing the weather data. So you can see on my heating coil, there's a minus 35 degrees to 85. I'm going to double left click on the white screen, or right up here at the top, there are project properties. I'm going to come in here now, just under weather data, and you'll see I'm in Alaska. You'll see the load on that coil, if I move this down a little bit, is 148,900 BTUs. Let's change that to where we're located, USA. We're actually out in Salt Lake City, Utah. So we'll just kind of go down to that. I missed it there. Right there. And then Salt Lake City International Airport. So you'll see our temperatures are 14 degrees outside, not the minus 35 to 85. So that would be the load on the coil now. So that's how you're going to change the weather data basically anywhere around the world. The other question that was asked is looking at static pressure. So I can click on this fan, whether it's the fan there, and then you'll see there's a summary of internal static pressure from coils, backdraft dampers, fan inlets, outlets. Okay, clicking on the coil down here is the same thing. It's the same fan. Okay, you can also right click with your mouse to look at the static pressure with the path of that makes up that 0.9. And then you can also go in a duct, as I did right here, and enter a 50-foot length on a supply there. It's going to multiply that by a fitting factor, or you can use fittings if you want to show fittings there. Multiply it by that 0.05, and that's what came up with the 0.17. That's part of the internal and external static pressure. There it is, the duct word right there. So that's the static pressure on a system. The head, as always, you just click on a pump as well, go to the major things, control valves, and you can actually click right on there and it'll take you right to that control valve. Maybe you want to say, well, no, I want that to be 5. Then as we hit apply and go back and look at that, you'll see now it's 5 feet. So there's the major things in the system. There's some minor things that would be valves and the piping. So once again, I went in that pipe right there, and if I close out of this, you kind of see where that was. And clicked on there and entered a length under key data, 100 feet, and multiplied it by 1.5, then by the 3.3 feet per 100 to come up with the head loss there. So anyway, that's just a quick summary. And once again, I can show the pipe head loss of that system there. The other question there, to building a simple system drag and drop. So let's just take a few minutes. Now, I'm going to do it the slow and hard way here. We have a much simpler and faster way. You can just go into these wizards here, answer questions on an air handler system, answer them on a hydronic system, and automatically build these. But for dragging and dropping, I'm going to come to the air handler. I'm going to go to a box, put that on the screen. I'm going to go grab a supply fan, some type, put that in there. You'll see it's going to give me another fan for my airflow diagram where I can see some of the calculations take place. You can actually add a plenum if you want, or when you insert a component, it automatically puts one in. Let's go hydronic heating coil. It's going to give me another one for my airflow diagram, and then another one for my hydronic diagram. Then last of all, we'll just come in here and put a damper in there, right? We're going to grab a outside air damper. Put that in there. You can put a louver in that air handler. Many times the louver is in a mechanical room with a space. So we'll just come to the air tab there and just go grab a louver that would be like in a wall. Okay. Then the last thing I need here is a space. We'll just go grab a space there. The space is where all the kind of information from a loads program exists. So the CFM, we'll go 2000 CFM this time. Temperatures, heat loss, if I had heat loss in a space. So this is load data that can come in from your loads program. When we import your loads program, it automatically fills this data in a space. Now I'm going to connect that up. Doesn't matter, backwards to forwards or forward to backwards. And you'll see that calculations start to take place. So now 14 to 85 with 2000 CFM. You see my load's a little bit more there. Then I can actually go grab nice lock and bar boiler from the tab there. Put that on the screen. And then just start, gave me a component for to size my gas piping. Right, then I'm going to hook up that system there. Flows, temperatures start to change. I can actually come up here and just copy, paste, put that pump down in here, move that piping over a little bit, put the air separator from there, copy, paste. You'll notice when I highlight or go over a duct or pipe, that's where it's going to go in right there. So you know for sure. Then if I cut that, it's going to cut it from there and put it down here. So you always want to copy, paste instead of cut. Just wanted to show you that as an example. So there's my system, built for dragging and dropping, and then I could come over and grab another meter if I wanted, or just grab that one, and then hook up the system. You see up above, I actually put in a little PRV to reduce the pressure up there on that system. So then you can always highlight, drag a box across, highlight, go in and look at your diameter on items, duct sizes, all that information to annotate your drawings. Then obviously we have the schedules that you can start creating and selecting equipment as well. Anyway, hope this has been helpful for a few of you guys out there that ask about this. Be sure to sign up for a free one-on-one demo, or let me help you start a project. Hey, thanks for watching.